In this example, we have log base x of 4 is equal to 1/3. This is a logarithmic equation where the base is unknown and we need to solve for the base. So our first step is going to be to write in exponential form. So we want to write this in exponential form. So we'll have a base x raised to the 1/3 power is equal to 4. Now, in the previous problems, we looked for the same base, but this base on the left-hand side of this equation is unknown. So our second step here is to isolate that base. So we want to raise both sides of the equation. EQN stands for equation, to a power to eliminate the exponent of x. So we want to eliminate that 1/3, eliminate the exponent of the variable. So I'm going to highlight here so you know what I'm talking about. So the exponent of the variable is 1/3, and we want to eliminate that. So we're going to raise both sides. Let me rewrite this. X to the 1/3 equals 4. We're going to raise both sides to the 3rd power, because if we raise both sides to the 3rd power, using our power to a power rule, 1/3 times 3 is the first power. That would be 1, is equal to 4 cubed. So x is equal to 64. So 64 to the 1/3 power is equal to 4. Now, if you're not sure if this is true, you can look back at your examples and you can see that this was the very first example that we did when we didn't know what 1/3 was. So when we didn't know what 1/3 was, we had the same exact equation. Okay, let's try another example. Log base x of 32 equals -5. Log base x of 32 equals -5. We're going to take our base, raise it to the -5 power, and that's equal to 32. Now I want to raise both sides to a power that's going to eliminate that -5. So what can I multiply -5 by to undo it, to give me a power of +1? Well, we know we're going to raise it to a negative, so that the negative times the negative gives us a positive. And then we have, 5 times 1/5 is 1. So I'm going to raise both sides to the 1/5 power. That's going to give us x to the 1st power is equal to 32 to the 1/5 power. Well, 32 to the 1/5 power is the same thing as the 5th root of 32. And the 5th root of 32, what times itself 5 times is 32? It all goes back to those exponents. 1 squared through 25 squared, 1 cubed through 10 cubed, 1 to the 4th through 5 to the 4th, 1 to the 5th through 4 to the 5th. And this would be 2 to the 5th power is equal to 32. Therefore, the 5th root of 32 is 2, because 2 times itself 5 times is 32. Okay, I believe we have one for you to try. So let's see if you can try this one. Go ahead and give it a whirl and press pause when you're ready to come back and check your answers or your answer. Press play, and I'll actually be working this one out in case you do get stuck. So try as much as you can on your own and then come back and see how it's done. Okay, you might have already known how it's done because maybe you tried this one, you said this isn't really too bad because that 5 times the square root of 5, it keeps popping up. X to the 3 power is equal to 5 times the square root of 5. So you know here what you need to do. x to the 3/2 is equal to 5 to the first times 5 to the 1/2. And 5 to the first times 5 to the 1/2 is 5 to the 3/2. So we have x to the 3/2 equals 5 to the 3/2. If I want to go through all the motions, I can multiply or raise both sides to the 2/3 power, and then multiply power to a power. That's going to give me the first power. And then 5 to the, indeed, that's also going to be the first power. So x is equal to 5. X is equal to 5. When we come back, we are now going to solve log equations when the argument contains the variable. So now the argument is going to contain that variable. And there's just one additional step that we're going to have to look into to make sure that our answers are workable.